Hello and welcome back to IXL tutorials. This is Mr. Duffick, and today we are doing IXL M8, which is coming up with proofs involving triangles. Okay, so this is very similar over to proofs we've seen, especially back in the D category of IXLs, except they're going to give you triangles this time instead of diagrams with transversals and such. And you're going to have your two-column proofs. You're going to have your statement, so a statement of fact, and then the right column is going to be the reason about how that statement works. What is the mathematical justification for that statement? So one of the differences you will see in this IXL is the variety of reasons you have when you're answering these questions. Okay, there seems to be a lot more. I'm not going to read every single one. A lot of them are, definition of midpoint, definition of equilateral triangle. They're fairly obvious. If you know what an equilateral triangle is, then you should understand if you should be using that reason specifically. So keep that in mind. Triangle, angle, sum theorem, all this stuff is pretty obvious. So what we will do is we'll look at the statement here, and we will see which reason corresponds with that. So the statement here is the measure for angle G, H, and I all add up to 180 degrees. Okay, well, how do we know that? What does that sound like? How do we know three angles of a triangle add up to 180 degrees? Well, immediately you should go, well, that's just the triangle angle sum theorem, right? All three angles of this triangle have to add up to 180. So we'll see if that is an option here. And it is, triangle angle sum theorem. Select that. There we go. Okay, next. RV and SU, so RV and SU are congruent, or I'm sorry, parallel. So this line is parallel with this line. Good to know. Complete the proof that the measure for angle TSV, so this entire angle here is equal to R plus V. Okay? Without using the triangle angle sum theorem. So we'll go down here to our statements, and it says the measure for angle TSV. So again, the entirety of this angle S right here, I guess, these two little angles. And that's going to equal TSU, so this half, plus USV, so this half. So we know that these two halves are going to equal this whole. Okay, let's figure out why that is. Additive property of angle measures. Oh, maybe. Property of length? No. All right angles are congruent? No. Angles forming a linear pair sum to 180. We're not dealing with the linear pair here. That's with the straight line. Definition of angle bisector? No. Definition of complementary angles? No. Definition of equilateral triangle? Nothing to do with an equilateral triangle there for that statement. Definition of midpoint, no. Perpendicular lines, no. Supplementary angles, two angles that add up to make up 180 degrees, no. Hypotenuse leg theorem, no. Isosceles triangle, nothing to do with isosceles triangle. Parallelograms, quadrilateral, and vertical angle theorem. None of those are going to apply. So the one thing that could apply is the additive property of angle measure. And that's just saying when you add these two angle measures together, it's going to add up to another one. So we'll do that one and submit. Good. Okay, next one. Let's see, HJ and JK are parallel, just like the last problem. We want to prove that J plus K plus JKH, so J or JHK. So these three, you want to prove that these three angles add up to 180 without using the triangle angle sum theorem. Okay, so now they give us two reasons to prove. So we'll go down. The first one is that what we're given is HJ and GK are parallel. Okay, the statement we need to find a reason for is the angle G right here is congruent with IHJ. So we're saying that angle G is congruent with this angle right here. And why is that? Well, if you look at it and maybe tilt your head a little bit, and you know that these two lines are parallel, right? You can kind of imagine this line goes on a little bit and this line goes on a little bit. That means this one is a transversal, right? So we have a line that goes on, a line that goes on, and we have a transversal here. Meaning the angle here and the angle here are both on the same side of the transversal and on the same side of their respective parallel lines, meaning they are corresponding angles. So that is definitely a solution here. So let me see if they have that. See, alternate exterior, no. Alternate interior angles, I don't think so. Converse, alternate, converse. I don't think it's a converse of anything. Corresponding angles postulate. Same side exterior, same side interior angle. So we're going to go with corresponding like we were saying. And then down here, we have the measure for GHK, so right here, plus IHK. So this entire thing right here is equal to 180 degrees. So this little angle here plus this angle here adds up to 180 degrees. How do we know that? Okay, well this one is a linear pair of angles, right? This angle plus this angle plus this angle has to add up to 180, right? You can imagine us drawing kind of that little arc I like to draw with the 180. But it's just saying this angle right here and then plus this very large angle equals 180. Same deal. Okay, all three add up to 180, or these two plus that one add up to 180. Either way, it is the linear pair of angles. So let's see if that is a solution here. Let's see. Angles forming a linear pair sum to 180. That's going to be it. Okay, submit. All right, and that is usually where I stop with my students. So I'll see you on the next IXL tutorial. Study hard, stay safe, and bye-bye.